To start out the Coulomb's law notes, I draw a couple pictures over on the side of the paper, and so they're a positive and a negative charge. And so obviously from the picture you can see that in A, the positive and negative charge are closer together, and in B, they are farther apart. So I asked them to stop and think for a second about which one would have a greater attraction, a greater attractive force between the two. So I gave them about 30 seconds to think about it, which one would it be, and why would they think that. And then I have them turn to their partner and ask their partner about that and see what we come up with. And then I have my students raise their hand and come up with which one would be a greater attractive force, and then they come up with A, and so I ask them why, and we usually come up with that they're closer together. So if the charges are closer together, they have a stronger attraction or repulsion. So what type of relationship is that? And then we lead into that they're inversely proportional. I do the same thing with this second example. They're both positive and negative charged, but A and B have different amounts of charge, and so I asked them to do a think, pair, share again, think about which one's going to have a greater attraction. They talk with their partner, and we come up with that B is going to have the greater force, the stronger attraction, because there's a greater amount of charge. And so we talk about how those are directly proportional. And so from these two relationships, we derive this equation, and so we start with the force equals, and then we look at the charge is directly proportional, so that goes on top, the separation distance is on the bottom, and I tell them that the distance is squared in order for this to work out. And then we talk about that there's a constant here, and that constant is going to help us to cancel out our units and get our force on the right level of numbers that we're looking at. And so then after that, we go through these equations, and after rearranging them, we actually try some of them. So I do number one with them, and as you can see here, I go through how we can cancel all of these out. Why do we have newtons in the end? You cancel out the Coulomb squared here, and then you cancel out the meter squared, so we're left over with meters, so they can see that's why K has those units. And so then I have them do 2 on their own, see how they do, and then I have them do 3 on their own and see how they do from there. So that's kind of how we go through the Coulomb's law discussion. Sometimes it takes a little bit longer than I had anticipated, but I really want them to derive the equation. That's a really important part to me, for them to look at the relationships between the variables first, and then use those relationships to come up with the equation, what that equation would be. So that is why I go about the notes that way.